All right, so let's start with the overhead quizzes. Overhead variance quiz. And let's go through some questions. There are only going to be 6 questions, so how about we go through just a full instance of it and then have some requests if you have any. Were you going to request one? Yeah. What were you going to request? I'll write it down.
It's a variable overhead price variance.
Okay. Is it an open answer?
No, it's actually
variable overhead price variance. Okay, well, I'll make sure. I'll put a note so that at the very least I'll come back and you can ask about that one if you want. Okay. All right, so this question says, a firm's static budget predicted $65,000 in fixed overhead costs. The firm's PDOH, which means predetermined overhead, and sometimes it has the rate in there as well, but doesn't always have to. PDOH rate is $50 per machine hour. 60% of which it was for variable overhead, meaning the remaining 40% is for the fixed overhead, which is going to be relevant to this question. The firm's actual machine hours were 3,600. The firm's actual fixed overhead costs were 85,000. All right, so what I did in this question is I gave you actual box. I gave you the static box. And I gave you the building blocks to build up what the applied cost was. Now, if I were just asking for the spending variance, you could ignore all those building blocks because I just want to know the difference between these two. Fixed overhead spending variance is just going to be 85,000 minus 65,000. But I'm not asking for that. Unfortunately, I'm asking for the volume variance, fixed overhead volume variance. And so you need to know 65,000 minus some number here. So let's build up that number. This, no, actually, I think it works better the other way. Yeah. All right, so this is a FOH volume variance question. So we know we're going to have to subtract 65,000. That's our static budget. Fixed overhead cost. And we need to figure out what the applied, how much fixed overhead cost we applied was. So I'm going to figure out something. I'm going to copy over. We have $50 as our PDOH rate. And 0.6 is the variable portion of the PDOH rate, which means that 1 minus 0.6, or 0.4, 40%, is the fixed portion of PDOH. So the PDFOH is the overall PDOH rate times the 40% that is referring to fixed overhead costs. So for every machine hour, we are allocating to the job or the order or the unit $20 of fixed overhead cost. And our actual machine hours, which is our cost driver in this case, is right here, still highlighted, 3,600. So we can multiply that 3,600 machine hours times the $20 per machine hour of fixed overhead costs we're applying to figure out how much applied overhead costs we have. So we have 72,000 applied overhead. All right, so the volume variance is going to be the difference between those two. 65,000 minus 72,000, which is going to be $7,000. Negative $7,000. All right. So the question of favorability comes in. Is this a favorable or unfavorable? Yes, it's favorable variance. Okay? We can use the same rules for signs. Negative variances are favorable, positive or unfavorable for the overhead variances. Because of the way we've set up the mountain range, our left-hand side minus the right-hand side will always give us a negative if it's favorable or a positive if it's unfavorable. And you can also check that to say, okay, well, applying $72,000 of fixed overhead cost is just a function of this PDOH rate fiction that we have. There's no reason why that would be expected. Even the static budget didn't expect that much. That's just a function of how many machine hours we used. And so we're moving closer to reality by going away from the applied cost towards the static budget cost. So as we go closer to reality, further leftward, then the costs are going down, and that's favorable that costs are going down as we get closer to reality. Okay? Yes.
So it's static minus actual, not actual.
Static minus the applied. This is the applied one, the 72,000 B8. We don't end up using the actual cost in this question at all. The 85,000 actual over here, we don't end up using that at all. We're just looking at these two right here. So the static budget minus the applied budget. Yeah. Yeah, with fixed overhead, we would have price and quantity variance, but that's not really useful for a fixed overhead, for fixed costs like this. So we merge those together into just the overall spending variance, and then we tack on an extra little square to the right of the static budget, which is the applied cost, just for fixed overhead variances. And then we follow all the same logic of we're taking the left-hand one minus the right-hand one. In this case, the left-hand one minus the right-hand one gives us negative 7,000. Does that make sense? All right? Yeah, Peyton.
The spending variance is the static minus the actual.
The other way around. It would be the actual minus the static. Yes, it would be $20,000 in this case. If this kind of question, or this question itself has a spending variance of 20,000, unfavorable. So if it were asking for that in this question, that'd be okay. All right, let's jump over to the variable here. This is fine. Variable overhead costs, going to work very much like our direct labor and direct materials costs. We just make sure we have right in our head what is the price and what is the quantity. The price is going to be the variable portion of the predetermined overhead rate that we're charging. And in this case, all the pre-DOH is variable. There's no fixed portion at all. So the whole $20 is the variable portion. And the quantity is the quantity of cost driver that's being used, either the standard quantity of cost driver or the actual quantity of cost driver. I'm going to be using the variant. Then when we have those two things nailed down, we can use all of our instincts from last week on variable overhead variances here. All right, so this firm applies variable overhead with a standard rate of $20 per direct labor hour. Doesn't label this as a PDOH, but that's what that means. We assume there's no fixed overhead, this problem. The firm's static budget predicted 95,000 finished goods per unit, and the standard is for 2 direct labor hours to be used per finished goods unit. So what that means, so let's go VOH price variance question. We may or may not need this, but just in case, we have static budget volume, finished goods units. That's what that means. Of 95,000, excuse me. And there should be 2 direct labor hours per finished goods unit, DLH per FG unit, which means that at the static budget, we would have predicted 190,000. That's the standard quantity at static budget. That's to say static. Okay. This period's actual finished goods units were 97,000. Okay, so let's do that again. 97,000. Actual volume in finished goods units. So given our actual production, our actual volume, we would have budgeted 194,000. Swinging a bell, flexible budget. So we use the more traditional squares of actual, quasi-budget, flexible budget, and static budget. Volume variance, quantity variance, and price variance. And so that 190,000 would be part of our SQ in this square. 194,000 is the SQ in this square right here. Let's keep going. The firm's actual direct labor hours were 150,000. And the actual total variable overhead costs were $3.6 million. All right, so I gave you this square, 3.6 million. And I said that is 150K times the actual price. I didn't tell you the actual price, but I told you the actual direct labor hours, the actual quantity of hours used were 150,000, and it resulted in 3.6 million overall cost. So we can take that, we can get out the actual price out of here. Let's do that. We have 3.6 million. We have 150,000. That's our actual VOH cost. And this is our actual direct labor hours. This is our actual VOH per DLH rate. So we didn't know at the time. We thought we were going to use our standard rate was $20 per direct labor hour. In reality, we ended up using $24 per direct labor hour. All right, now this, we're trying to get the price variance. So I went through this just to show you what's in the question. It's not relevant to this particular version of the question. Maybe you have other ones that have a similar stem, but they're asking for a quantity variance. And so hopefully that helps you get the standard quantities right. This question right here is asking for the price variance. And so we need to compare this 3.6 million and the quasi-budget here, which is actual quantity times standard price. Standard price, like it says, is $20 per direct labor hour. And actual quantity we already have. So we can multiply those out. I'm doing the full squares method right now. I can say, no, I don't have it. 20 is the standard price. And I can take that, multiply it by, at the standard price, those 150,000 direct labor hours should have cost us $3 million in variable overhead costs, not the actual 3.6 million right here, which is why it's a $600,000 variance. Is that a favorable or unfavorable variance? Unfavorable. I like that. Good chorus there. Got a lot of people answering that. Good. We're on the right track. Good. It's unfavorable. Yeah. Prices went up. It's very easy to see when we have the subtraction that way. 3.6 is the actual. 3 million is the quasi-budget amount. So clearly, as we're going towards reality, costs have gone up. Also, it's that means that results in it being a positive number, which is unfavorable. Okay, if we did the algebraic way, actual price minus standard price, and I gotta put parentheses in, times the actual quantity, we get the same answer. We just formulate a little differently. Get these two rates, subtract the difference between these two rates times the actual quantity will give us the price variance as well. Let's copy that over. Okay, questions on that one? Cells you want to see? All right. right, here's a very similar question, which makes me glad I did all this here to kind of get get the pump primed, if you will. But it's asking about quantity variance. So this kind of stuff that we did in the previous question is going to be relevant to this question, even though it wasn't relevant to the previous question. So let's go with the VOH quantity variance question. And I'm going to copy some stuff over here. So our static budget volume is 6,110. We have 1.5 direct labor hours used per finished goods unit, and the actual finished goods units were 6,500. Oh, wrong tile. All right, so you're going to be tempted to use this number, but don't use that number. That's the standard quantity in the static budget based on the budgeted finished goods units, static budget finished goods units. We want how many we would have budgeted if we knew that actual production was going to be 6,500 finished goods units. Well, at 6,500 finished goods units and 1.5 direct labor hours per finished goods unit, that means we would have budgeted 9,750 direct labor hours. That's our standard quantity. And so we're going to compare our actual quantity to that standard quantity. So actual, let's put that 9,500, actual quantity, or AQ, is fine, abbreviate it. And then we need to, if we're doing algebraically, quantity variance equals actual quantity minus standard quantity times standard price, right? Because we're over here on this side. We haven't pulled the lever of price yet for the price variance, so we're still in the standard price land here. So we copy over that standard price of $150 per direct labor hour, right here, or our PDOH rate. So I'm going to take the actual quantity minus the standard quantity and multiply that by the standard price. So I get 37,500. What kind of variance? Favorable or unfavorable? Favorable. Okay. Because it's negative, and double check, we can say, oh, well, our actual quantity, 9,500, was less than we would have expected to have. We used fewer direct labor hours, leading to less variable overhead charges to the units. Great. Questions there? B38. Yeah, right here. Yeah, I'm just putting this formula into the cells. So the actual quantity minus the standard quantity, and then that difference in parentheses times the standard price.
Okay, so we took the second box, subtracted it. We subtracted the third box.
Yeah, we're doing, yes. We are doing this. We've just rearranged it algebraically to be like this. So it's actual quantity times standard price, which is this box right here, minus standard quantity times standard price. And rearrange, we can pull out the standard price and just have these two, actual quantity minus standard quantity. We can rearrange it just to make it a little simpler. If I went out and fully did the calculation to make it into boxes, I would do this. I would take actual quantity times 150,000. So that's the quasi-budget box. And standard quantity times standard price. The standard quantity of the flexible budget times standard price, just to be specific. This standard quantity, not this one up here. Don't get tempted by it. This one right here times the standard price here gives us this amount. And this is the... And so you subtract those two, and you get the same answer.
I like how we did it, though.
I tend towards liking that one better. There are some questions, like the price one we just did, where it lends itself to subtracting boxes because I gave you the number for a whole box. So I did some of the work already, and if it's easy enough to do the other box, then you can just do the box. But I tend to like this equation, the same one. But yeah, I tend to like the algebraic equations a little better. Okay. Other questions on that one? All right, let's skip over this, or should we do the open answer one? Because now it's open answer. At least psychologically, it makes it harder. Probably literally makes it harder as well. But maybe there's also a psychological component, like, oh no. I'm also going to add that difficulty to it. All right, so this is the Padme Makeup Incorporated. Oh my goodness. Who wrote these things? Variable overhead, quantity variance. Open answer. All right, so quantity variance is the same thing we just did. We need those same details. We can either get AQ times SP minus SQ times SP, SQ at the flexible budget, remember, or we can do quantity variance equals AQ minus SQ times SP. Still remembering that this SQ, either one of these SQs is standard quantity at the flexible budget of actual production, actual finished goods production. Okay, so we use a predetermined overhead rate, a PDOH rate, to allocate overhead. The firm incurs variable and fixed costs. Okay, so we're going to have to peel out how much of the PDOH is due to variable overhead cost, so we can use just that portion. The firm's PDOH rate is $12.04. I'll write that down. PDOH rate, $12.04. And 52% of that PDOH is for the variable overhead costs. The remainder is for fixed costs. So this is the variable portion, 52%, 0.52. So right away we can say our standard price is 6.26, rounding it a little bit. Okay? Right away we've got standard price, which is going to be important because look, that's one of our inputs to the equation. Either way, we've got SP in here somewhere. Okay, so we got one of the three we need. During the period, Padme Makeup Incorporated actually incurred $24,374 in variable overhead costs. And I'm going to ignore that sentence because that's giving me information about the actual cost. That's the box right here. $26,374 is this box. And I am calculating quantity variance. I already saw the bolded question stem, quantity variance. So I only care about these two boxes. I'm going to ignore that sentence. The firm's static budget expects 2,250 units of cost driver to be consumed, but 2,900 units of cost driver were actually consumed to produce 670 finished goods units. The firm has a standard of 3.4 cost driver units per finished goods unit. All right, so we have actual quantity. Great, that we can pull that out. There are like four numbers we went over here. And I know one of them is actual quantity. Great. That's the actual quantity of the cost driver. What's the last thing we need? We got AQ. We got SP. We need a standard quantity. All right. So from these three numbers, or some variation of three numbers, we need a standard quantity. Now, we'll be tempted to say, standard quantity. Don't give in to the dark side there. That's the static budget standard quantity. We're going to have to use this number and this number to figure out the standard quantity at actual production. So our actual production, we actually consumed this actual quantity to produce 670 finished goods units. Oh, okay. So 670, actual production. Sometimes I call it actual volume. Sometimes I call it actual finished goods units produced at volume things. I don't think I've ever actually said that, but those are some of the words that I use sometimes to talk about this stuff. But it's the same idea. Actual production volume is 670 finished goods units. And our standard, the same standard we use at the static budget time to create 2250 as our static budget standard quantity, our standard is 3.4 cost driver units, which is the quantity we're talking about, cost driver units, per finished goods unit. So we could take this 3.4 and we can multiply it by the actual production, and that's our flexible budget standard quantity. Use this one. Okay, so now we have an SQ, an AQ, and an SP. So we can just put them in the equation. I wrote it out right here. I'm going to use this one like I like to use. I like to use the more algebraic one. AQ minus SQ times, wrong one, SP. There it is. I'll label these things, and this is what I want to put units in there. Remember, we're doing a little exchange rate. We have finished goods units. We have cost driver or input units. So two different units. We have to have an exchange rate going on there. All right. This is the quantity variance. So that should be the right answer there. Okay, questions on this one? Sales to C. Yep. In variable overhead cost questions, variable overhead variance questions, I should say, the standard price is going to be related to the PDOH here, the predetermined overhead rate. Okay, let's move forward.
You might want to change it to cents. This is round final reserve cents.
Okay. There we go. There's another question that's very similar, asking the same thing. And another one that's very similar. Oh my goodness, we rolled all VOH quantity variances here, which was not the one you'd asked for. So let's see if we can find, do you still want to see something, variable overhead price variance question? Yes, over here. Okay. You're looking for an open answer one? An open answer? You were looking for a multiple choice one.
Well, I had one that was like, you probably would go for it. It was like I cannot be determined
Oh.
because of the lack of standard. I don't know.
Well, let's see if we can find that. That standard rate is in there. Those two words.
It is the standard rate at the top, but then there's like, I probably just.
Okay. Well, I'm going to look for this question at least for a little bit here. Spend some time trying to look for the question. And we'll also make sure we get an open answer one. I'm only finding this. They are a little few and further between. Try one more time. And then I might just see if I can read the question off of your thing there. Okay, let's see if I can read it off your computer.
I think it was Like now that we've went over it a couple times, that's what it looks like.
Okay, so this one, the firm applies variable overhead of standard rate, 5.75 per direct labor hour. No fixed overhead costs. Static budget predicts 600,150 finished goods units. Standard is half a direct labor hour per finished goods unit. So half of that 600,150 would be our static budget standard quantity.
Okay.
We actually produce 590,000 finished goods units, and actual total variable overhead costs were 1.75 million. Okay, so we're looking for price variance. Price variance is going to be actual price minus standard price times actual quantity. We have a standard rate, so that one can't be right.
Yeah.
The cannot be determined
Yeah.
aspect of it can't be right. So it's got to be one of the answers, of course. So read off to me real quick here. This is the price, VOH price variance, MCQ, not on screen. All right, so we have 5.75 as our overall PDOH rate, and that's all variable overhead. So that's our standard price. And then 570,000 is what's the actual quantity, actual finished goods production? 590,000. Okay, so that's actual finished goods, and that's direct labor hours per finished good unit. Direct labor, yeah. So that's our standard quantity.
I think I was just using the static budget, like projected units as necessary quantity.
Okay. Maybe. I'm gonna look at the question one more time. I think I've got what the problem is.
Like I saw that.
So we actually produce 590,000 finished goods, but I don't know how many actual direct labor hours we used.
Mm-hmm.
I don't have an actual quantity. Now, that's important for two reasons. Our price variance equation is actual price minus standard price, and it's multiplied by actual quantity. So the fact that if you use standard quantity that was at the static budget, it wouldn't matter because it's not in the equation at all. So we need actual quantity because we're going to multiply by actual quantity. Also, we don't have an actual price. We have how much is in this box, and if we had an actual quantity, we could divide this box by the actual quantity and get the actual price, just like we did here. We have the total number, we divided it by the actual quantity to get the actual price. We figure out the actual price. So we don't have two of these numbers. The problem is how I wrote out the cannot be determined option. I wrote the wrong reason we cannot be determined. So I need to look at that. That question is wrong.
Like
The one it's certainly the one it will accept is the cannot be determined. But yes, the way that answer is written, it's not true. It's not that we cannot be determined because we don't have a standard rate. We do have a standard rate. We don't have actual quantity, and that leads us not to have actual price. I could put either of those in and it would have been correct. So I need to fix that problem. It was me getting too cute by half with it, and being like, "Oh, cannot be determined." Because I should have just said "cannot be determined," and then I wouldn't have to give an explanation. That explanation wouldn't be wrong potentially then. Yeah. All right, let me fix that question. All right, and we'll make sure we get some variable overhead price variance open answer right here. Is that good? Okay. So Thrawn Strategic Solutions is a firm that uses a predetermined overhead rate to allocate overhead. All right, this is the Thrawn variable overhead price variance question. Okay, our PDOH is 11.25. 0.48 of that is variable costs. So we can multiply those out and get our standard price, $5.40. Great. Now, our actual variable overhead costs are $42,796. Now, in the previous question, I ignored that sentence because we were looking for a quantity variance, and that's this box over here. This question is looking for a price variance, so that box is important. So I'm not going to ignore that. I'm going to write it down, 42,796. Now, the firm's static budget expects 2137 units of cost driver to be consumed. That's not relevant to us. In fact, pro tip, I don't think any of these questions ever have that number being relevant. It's always there to distract you. The standard quantity at the static budget. I'm never asking for volume variance, so you don't need that number. Okay, but let's move on to what actually is relevant. 3,045 units of cost driver were actually consumed to produce 556 units, finished goods units. So what we have is a very similar situation to right here. I didn't give you an actual price, which is what we're going to need that for the price variance. But I gave you the overall amount in the box, 42,796, and I said we used an actual quantity of 3,045 to get that. And so we can derive what the actual price effectively is from that. So 3,045 is our actual quantity. And that means that the 42,796 divided by 3,045 gives us our actual price. And our actual price is $14.05 effectively, rounding it off. So we have our three variables. Where's our, I don't have it. Price equals actual price minus standard price times actual quantity. We have those three. Boom, boom, boom. Okay, so let's put that in. Actual price minus standard price all times actual quantity. So this should be the right answer. That should be a price variance. Is that making sense there? All right. Okay. Yeah, LT.
So we did 369 minus 866.
Yes, yes.
So we got that. So we got 369 by dividing actual cost by actual quantity.
Yep, exactly. Yeah, we did. Yeah. Yep.
What we did for 5.4.
We took the overall rate times 48% to give us the variable portion of the rate.
The standard price.
Yeah, that'll give us a standard price. Now, it's an extra step. That particular one, I want to note that it's an extra step I'm putting in there. That doesn't have to be there, but it actually is kind of reflective of what companies are doing in practice. To take overall overhead costs, whether they're fixed or variable, and just are allocating them based on these rates if they use the traditional absorption costing method. And then they have an overall PDOH rate, and a certain portion of it is for variable costs. And it kind of makes sense to have you make you get the actual, the standard price, the SP, by calculating it out of the PDOH rate times the percent. At least to me it does. Maybe it's not very nice. Either way. So
the difference between this and what we did last week is now we have to just work with this overhead.
Yep. I think the overhead, the variable overhead, the difference between this week and last week. Sorry, excuse me, the difference between what we did last week and what we're doing this week with variable overhead specifically. Fixed overhead is a different animal, but with variable overhead is to put it in different terms. I think this is what you said, but in different terms, is that we've got the terminology is a little different. It's these words are going to be a little different. But if we learn that the PDOH rate, especially we figure out which portion is the variable portion, if there is a variable portion, that's our standard price. Then we can translate that. We can just take everything we learned about standard price last week and convert it over and use it right now. Good. Yeah. Yeah. Yeah, just took actual cost divided by the actual quantity. Okay, what I think I want to do, if it's okay with you, is jump over to mix and yield, the other quiz. And if we make good progress there and we've got like a few minutes left, we'll come back and do another fixed overhead problem, because we've done a lot of variable overhead problems so far today. We did some fixed overhead at the very beginning, the boxes up there. I think it was like just one question actually that we did fixed overhead. But let's come back to that. We'll make sure we get there. Oh, here we are. Okay, so mix and yield. All right, let's reorient ourselves. Wait, make a note here. Okay, mix and yield are a way of dealing with quantity variances when we have substitutable inputs. Basically, the idea is we're going to separate out a mix variance to deal with the fact that we have substitutable inputs. And then the yield variance is going to stand in as more the traditional understanding of a quantity variance, what's left over. But they give it a different word because it's not just a normal quantity variance, it's had the mix portion of the variance stripped out of it. The amount of the quantity variance due to mix differences, variations from away from the standard mix, stripped away from it. All right. Okay, so let's talk about that. Let's do one of these questions right here. In fact, to get most bang for a buck, let's jump over to an open answer one, since I will certainly get a request for that eventually. That's this one right here. All right, we have two inputs, x and y, and they're substitutable. Our mix is 2 units of x for every 16 units of y. Okay, so we have mix. No. I need to put that over. All right, so x and y mix variance open answer question. So x and y, I'm just going to start building up my table here. I know I'm going to need total inputs. I'm going to need actual mix, and then standard price, subtotal. And then I'm going to need over here almost the same thing, but in true variance fashion, I have one thing I'm changing, which is standard mix. All my talk about just pulling one lever, these two sides of the table have just one cell different, one column that's different. All right, I'm going to start extracting these from the question. This is building the table right here. Just building this table. Actual total quantity of inputs, actual input mix, standard price, subtotal, actual total quantity, and so on and so forth. The difference between H2 and C2 is what makes these two different. And then we're going to subtract and get the variance. I think what I'm going to do is just wrap text. That's how I'll make it make sense. All right, I want to get it all on one screen is the idea. All right, good. Okay, the price, 24 and 7. 24 and 7. Those are the prices right here. And the standard mix is right here, 2 to 16. So we need to convert that into decimals. Equals 2 divided by 2 plus 16. right? So we have total of 18 inputs here. 2 of them are going to be x, 16 are going to be y. So 2 out of the 18 total, 2 over 2 plus 16, that is, or 0.11111 is x. And 16 divided by that 2 plus 16. Of the 18 inputs that we have in this mix, 16 of those would be y, which means that 0.888889, or whenever we terminate it, 0.8 repeating is the percentage for y, typically. Okay, now we have an actual input of 10,000 units. And that's from both sides of the table. Both sides of the table. In our actual mix, we had 2,000 units of x out of that 10,000 units, which means 0.2 of our mix was x. And we had 8,000 units of y, that's right here, out of that 10,000 units were y, which means 0.8 of the actual mix is y. We just need to multiply across. Both sides, we're just multiplying all the way across, and then we sum at the bottom of each, and the difference here gives us our mix variance. Now, I've kept left and right the same. It doesn't, we can't, it's, every way I've tried to fit this into the mountain ranges has never worked, so I'm not going to try. But I have kept left and right the same logic. As the right-hand side one is the more hypothetical because it's at the standard mix of 11% x and 88% or 89% y. And the left-hand side is at the actual mix. Given the actual mix of x and y, we had 0.2, 20% x and 80% y. And so as we've moved more towards reality by taking from standard mix of these substitutable inputs towards the actual mix of these substitutable inputs, prices have gone up, costs have gone up, I should say. They went from 88,000, 89,000 to 104,000. So that 15,000 there is going to be unfavorable. It's positive variance, same thing, same sign rules. We can use the same sign rules. Unfavorable. Okay? Feeling okay about that?
So the mix variance refers to the difference in total cost.
Yes. We got an unfavorable variance there because the idea is we have something x is more expensive than y. And somebody, put their hand on the button for a little too long and put a little too much x in the mixture. Too much x chemical or too much x candy in the trail mix or whatever. And that's more expensive to us. So for the same volume of trail mix, for the same volume of chemical, it's a more costly mix. It's a more costly chemical because we put too much of the expensive stuff in there. Yeah, instead of making it gold plated, we made it solid gold, if you will. Put more of the expensive stuff in there. And so that's what makes it unfavorable. Simply changing the mix to be the more of the more expensive variety has made it unfavorable to the tune of $15,000. Yeah. So yes, it's the total cost. Your question was, that's the difference between the total cost and the two? Yes. And the way it always ends up working when we have these in these questions, at the very least, because we have two that are substitutable. So if one goes up, one goes down. It's always going to be the case. If you looked line by line, one went up from 26,000 to 48,000. One actually went down from 62,000 to 56,000. But the downward mode, the cost we saved on not using as much y was very much overwhelmed by the extra cost we spent by using too much x, because x is just that much more expensive. So the net of those two, those two movements, one going up, and the other going just a little bit down, gets us this 15,000, 1,100, which is why we need that. That's me saying in verbal speech why we're using the totals. The difference between the two totals is the variance there. These two total amounts. Okay. All right. Let's do yield. We got to do it at the very end of class Tuesday. That wasn't very nice to yield. All right, so here's a yield question. This is not too dissimilar from the one we did. And hopefully we'll get a little more mileage out of this. So yield laborers. So we have two different types of laborers. We have senior laborers. Ooh, I didn't push tab, I pushed caps lock. And we have junior laborers. Senior laborers, due to their experience, are more costly. They cost us more per hour. Okay, now I did something I did something between Tuesday and today. Tuesday, we had a question like this, and then it said like something like 6 total hours is the standard input. So it had some difference between the sum of these two and the input to finished goods ratio. I went through and I got rid of all the questions like that between then and now, because for one, they weren't programmed to be calculated that way, so the calculations were all off. And two, there's no point in making that complication. Okay, so we can just say for every finished goods we have 1 senior laborer hour and 3 junior laborer hours, because the standard hours of input per finished goods unit is always going to be 1 plus 3 or 4 or whatever the sum of those is. So I can save myself a step. There was that last little step from Tuesday where I tried to convert it from 4 hours to 6 hours, and it was confusing to even say what I was doing. So we don't have this step. Just very simply, we have an actual yield given to us, and I want to jump to the textbook here to say why we care about actual yield, because it's part of the equation. Actual yield. We have a whole thing here. Actual yield. We changed the name to yield because we're trying to differentiate it from the normal quantity. It's actual quantity is the idea. Also, we're trying to also point out something here. All right, yield is weird. Let me just break this to you. Yield is going to be weird, and all of your rules about favorability are going to be reversed. I don't know all the reasons behind this, but when we break up the quantity into mix and yield, it's probably the other way. But regardless, when we break it up, we stop talking about the quantity of inputs and start talking about the yield of finished goods. So instead of saying, well, given 100 units of finished goods production, we use this quantity of inputs, direct materials or direct labor, we have switched that around and said, given 1,000 units of direct materials or direct labor, we yielded this amount of finished goods. So if we keep yield constant, if we keep the number of finished goods constant, then higher quantity of input to get that amount is bad. Oh, I got 1 unit of homework done and it took me 2, 4, 5, 6 hours. That's not fun. I've actually been there. Those questions are not fun. Lower is better. Oh, it took me 2, 1/2 a minute. Great, got that down so I can do the test well. If we don't hold yield constant, instead we hold the quantity constant, okay, it took me 2 hours, then I got 5, 10, 15 questions in those 2 hours. Higher is better. Okay, so we flipped it around. Actual yield here is the quantity of finished goods we're yielding. We're given a set number of inputs. So we've yielded more or less. So actual yield minus standard yield, we actually want the number to be higher, more finished goods for the number of inputs we put into it. So our actual yield is in this question here. Other one. I'll move it so it's closer. Our actual yield is the 10,500 finished goods units. We don't know the standard yield. And also, we don't know standard price at standard mix yet. We've got to calculate those two things out. It's relatively simple. And if I set up the table a little differently, it'll be even easier to see. Standard mix, standard price per hour, 1 to 3, just copying over these numbers. At the standard mix, we have 1 senior labor hour and 3 junior labor hours, and they cost us 20, 4, and 10 respectively. Just multiply across. So for every finished goods unit, we have $54 of direct labor going into it, because we have $24 of senior labor cost going into it for the 1 hour of senior labor time it takes. And we have $30 of junior labor for the 3 hours at $10 per hour for junior laborers it takes. So that is the standard price at the standard mix. So go back to the equation. That's the standard price at the standard mix. So we did. Okay, what I'm saying that I did ultimately is standard price of a batch of input units at standard mix, so that's this right here, divided by finished goods units per batch. When I said I fixed the questions, and so now they don't have a difference between, like, they wouldn't say 6 here or anything, is I made the finished goods units per batch equal the number of batch elsewhere. So it's just, might as well just say 1 as the denominator here. I simplified that math. Don't want to have that complication in there. Also, but the point is, you create this table out here, you get the total amount of cost, standard price at standard mix. That should be it right there. Yes. Okay, now we still need to figure out standard yield. Finished goods units you'd expect given total actual inputs at the standard mix. Okay, we actually used 36,750 total hours. It takes 4 hours per finished goods unit. So we can divide that by 4, and that's how much yield we would have expected. That's our standard yield. Actual direct labor hours, 36,750, and then DLH per finished goods unit, 4. We can divide by the 4 and get a standard yield of 9,188. So what that means is, if you just presented to me your work at the end of the day, and you said, well, we used 36,750 total labor hours. And it takes us 4 total hours of inputs per finished goods unit. Then I would expect, for that amount of labor hours, I would expect you to have 9,188 finished goods units to show me. That's the standard. Given those standards, at the actual total labor hours you used, I would have expected 9,188. We exceeded that, though. We gave you a bonus. We gave you a higher actual yield than that, 10,500. Okay, so when we do the equation, we take actual yield here, 10,500, minus the standard yield of 9,188. It's going to be positive inside here, and that'll mean the yield variance will be positive. And unlike all the rest of the variances, that's going to be a favorable variance. The yield is weird. It almost is spelled the same. Just change some letters around. Yield is weird. It has the reverse in terms of favorability. And hopefully I got that correctly into all the questions. So take actual yield minus the standard yield. Oh, let's put parentheses. Times the standard price at standard mix. Like it says, actual yield minus standard yield, all times standard price at standard mix. And that should be our yield variance in that question. Now, it's not asking us for favorability. Other questions might ask you for favorability, but we know that's a favorable one, unlike every other time. We got a positive number, we knew it was unfavorable. Negative number, it was favorable. In this case, that's $70,875 worth of finished goods units above and beyond what we would have expected given the number of hours the labor is put into it. Got a bumper crop, if you will. Okay. How's yield doing? Okay. Want to see a cell? Yeah, let's do another mix variance. We've got a mix here. Try a different one though.
Could you do a multiple choice mix variance?
Sure. Sure. Does that work for you too, Elton? That's good.
Yes, it does.
Okay. All right. I don't know what I just started there. All right. So here's a multiple choice mixed variance. This look okay? We'll get some good reps with this one. So we have two chemicals, and because this is a very, very good example. We have chemical is going to be measured in volume, and so there's only so much liquid that can go together, and so how much it's going to cost us depends on whether this is like a gallon of our really expensive input, lots of our really expensive input, or a gallon of our really cheap stuff. There's a bartender joke in there somewhere. We're talking about watering down versus more pure. So we have two substitutable inputs, chemical A, chemical B, for our finished goods units. Okay. Typically, the firm uses 2 gallons of chemical A for every 3 gallons of chemical B. So we have 5 gallons total in like a batch or whatever, and usually be 2 to 3. Chemical A's standard price is $4 per gallon. Chemical B's standard price is $6 per gallon. Chemical A's actual price is $5 per gallon. Chemical B's standard price is $4.50 per gallon. Okay, I want to ask you a question. I could give you this as a little cheat, but I'm going to ask it from you anyway instead, because then I'll feel less guilty about like giving away stuff. Right? Remember what mix and yield variances are. They are a way of splitting up the quantity variance. Do you think we are going to use the actual price? No, why not?
With this one, we're doing it's our total inputs, and then it's our actual mix, and then our standard price, because we're just worried about the quantity variance.
Yeah. We haven't gotten anywhere into moving from standard price to actual price. That's all the way over here on the price variance side. We're just here in quantity variance land. And here, in quantity variance land, everything is at the standard price. So we can always ignore the actual prices there. Although I'll tell you, if you forget to ignore them, there may be a distractor choice down here occasionally that you will be tempted to choose. All right, so we can ignore these bottom 2 bullet points. We don't care what the actual price was. We just know that given the standard, chemical B is the expensive one, and chemical A is the non-expensive one, the cheap one. It looks like somebody goofed and used a lot. Well, no, wait. Yeah. Oh, this is an interesting one. We have 2 gallons of the cheap stuff and 3 gallons of the expensive stuff. This is supposed to be premium quality here. Looks like somebody goofed and used 3,000 gallons of the cheap stuff and 2,000 gallons of the expensive stuff. So it's not going to be as high quality. It's my assertion about it anyway. And so I already can guess whether it's going to be favorable or unfavorable. We overused the cheap stuff. So did the costs likely go up or down? They probably went down. Is that favorable or unfavorable? It's favorable. Now look, that's going to be bad for the customers. They're not going to like the fact that it's lower quality. But from a cost perspective, we save money. That's favorable. And that's to jump ahead to next week. That's going to be the critique of lean accounting. They're going to say, look, that's all good, but standard costing stops there and only rewards you if you do things like that. and it ignores the cost of, oh, hey, my customers don't like my goods anymore because they're all cheap and badly produced and low quality. That's going to be the lean critique of standard costing here. Anyway, to do this problem, to get back on track, since I don't know how to do that. So this is mix chemicals, MCQ question. So we're going to build our table, copy it down because I am lazy. Copy it down. And we have chemical A and chemical B. Total inputs, we have 5,000 gallons of total inputs. That's from right here. We produced 5,000 gallons of finished goods. Well, rather, we have 5,000 gallons of total inputs. 3,000 gallons of chemical A, 3,000 gallons of chemical B. That's why I'm saying that. Standard prices are 4 and 6. $4 for chemical A, $6 for chemical B. Our actual mix, now my old equations don't work. Our actual mix is 3,000 gallons of chemical A out of the 5,000 gallons used. So 60% of our actual finished product was chemical A. And 40%, 2,000 out of the 5,000, was chemical B. At standard mix, though, it says we use 2 out of 5, 2 divided by 5, 40% of chemical A, and 3 out of 5, 60% chemical B. Okay? So we've literally just swapped around the two items in the mixture, flipped them. Standard mix here, 0.4 and 0.6. Actual mix, 0.6 and 0.4. All right, copy over standard price here. Make sure we're doing standard price correctly on both sides. And this should be the right answer. And we already said this is favorable instead. Okay, so we have 5,000 total inputs. 0.6 of those in the actual mix were chemical A at $4 per gallon of chemical A. That's $12,000 of actual chemical A we spent or would have spent at standard price. Out of 5,000 total inputs, 40% of them were actually chemical B, times the $6 per chemical B gives us $12,000 of chemical B we were spending effectively at standard price in our actual mix. Given 5,000 total inputs at the standard mix of 0.4 chemical A and $4 per chemical A, we should have spent $8,000 on chemical A. And given $5,000 of total input, or 5,000 units of total inputs at the standard mix of 60% chemical B and $6 standard price chemical B, we should have used $18,000. So that ends up with $24,000 over here at the more actual mix, minus $26,000 over here, standard mix, the negative $2,000 favorable mix variance. Yeah, Corey.
For actual, is the mix based on the units or based on based on the gallons?
Of input.
Okay.
Yep. Based on the number of gallons of input. Out of a total 5,000 gallons we produced, or excuse me, I said it wrong. I said it the opposite. 5,000 gallons we put in. How many of those gallons were chemical A and how many of them were chemical B? Yeah. Now, it's difficult for me to create a mixed question where that doesn't also line up with how many units of finished goods we had. I would have to be assuming there would have to be some sort of chemical reaction where you start out with more and then some is left in a precipitate or it evaporates away or something like that. So you start out with 2 gallons, 1 gallon of A, 1 gallon of B, and you end up with only 1 gallon of chemical left over. But I don't think I have any of the questions that do that. I think it's always this plus this is going to equal the same as the finished goods you end up with.
I'm just curious, like on the open answer one,
Mhm.
the actual mix, we did
Up here?
yeah, just for that. Ignore that. Yeah.
Okay. We did, was it here we did this? I might have already submitted it. No, we didn't. All right, so this one's the favorable one. Okay, other questions on this?
We always use standard price for mixed variance.
Yes. That's right. Always a standard price. The only way I can think to help you remember that, besides saying make a note on your notes, is that mix and yield are breaking up the quantity variance, and the quantity variance only deals with standard price. Right here, quantity variance varies the quantities, and then multiplied by the standard price. We're over here on this side of the mountain range. When we go over this side, we might have to deal with actual price, because that's what the price variance has. What's this equation? Right here, actual price minus standard price times actual quantity. But since mix variance is over here, breaking down quantity into the mix and yield variance, it's always going to be standard price. Always, always, always.
I know our yield variance is kind of similar to this variance. Could you differentiate the system apart one more time between
The mix and the yield?
yeah.
So the mix variance is telling us mix variance tells us how much of our quantity variance is due to kind of messing up the proportions of different substitutable inputs, like different chemicals or different items in a trail mix or something like that. And the yield variance says, well, whatever you did in terms of individual units, how many finished goods units do we get out of the total inputs we put in? Like, how much did I don't care whether you put 20 pounds of candy and only 10 pounds of peanuts in the trail mix. I don't care. You had 30 pounds of inputs. Did that yield 30 pounds worth of finished goods trail mixes? Or did it yield more or less? Yeah, yield we jump to holding constant the number of inputs that we have. Did the outputs go up or down? Sorry, was that your question, or is that a? Yeah, I can go on. Yeah. Corey, did you have one more question?
I would say yield is the only time where positive is valuable. Okay.
Yep. Yield is the only variance we've gone over where you flip it. Flip the favorability rule. Okay. Now, I think what I'll do is when we get back in class after spring break, that Tuesday, we'll have a chance to go over as briefly as possible some questions if you have them. That Tuesday and the Thursday, we'll set aside some time so that we have a chance to go over these things before the 31st due date. And we'll get through all the chapter 8 stuff because we are just that good this semester. All you guys. Thank you. Have a good spring break.